Hello, everyone, and welcome to a new episode of Microsoft Sentinel in the Field. If you don't want to miss any episode, make sure that you subscribe to the channel and also follow our playlist in the link that you can see below. Today, we have to celebrate that actually we've been doing this show for now a full year. So congrats, Chris.
Congrats. It's definitely big. Hey, Javier. So today we actually have a really good topic about data normalization and data transformation when it comes to Microsoft Sentinel. And today we have our great friend, Ofer. Ofer, how you doing?
I'm doing fine. Thanks for having me and for your birthday, or the show's birthday today. Would be fun.
Thank you for coming, Ofer. So Ofer, can you explain at a high level what is data normalization and what is the critical role that it plays in a SIEM?
So normalization, an often used word, is essentially all about converting event data to a uniform format. Now, we have to remember that this uniform format is, as you expect, having the same field names, but also the same values for the fields. For example, let's say that an event reports a login. You want to make sure that the result of the login, whether it succeeded or failed, is conveyed in the field that is the same name across sources, so say event result. You also want to make sure that the values are the same, say success and failure. Some systems do it differently. Why is it important? So first of all, it allows us at Microsoft, as well as you when you use Microsoft Sentinel, to develop once the same content that you will apply to all similar sources, all the firewalls, for example, whether you have them today or you'll acquire them tomorrow. Secondly, it enables your custom sources. Say you have a custom application to utilize the built-in analytics in Sentinel that is not aware of your source. You'll have to create the normalization, to create a parser. We'll talk about it later, but it will enable our built-in analytics to use it. And lastly, the analyst, they have a hard time. They're in front of the log screen trying to sift through data, and consistent field names and values are really helpful for them to make their life easier.
Definitely. So thank you, Ofer, for that. And now that we understand the concept of data transformation and data normalization, can you tell us about the different features that are currently available today when it comes to Sentinel?
Sure. So Sentinel normalization starts with ASIM. ASIM is the Advanced Security Information Model. And at the end of the day, ASIM is a set of schemas or documents. Let me show you this document to start. Here you can see the documentation for the Sentinel schema. We have schemas for different event types, and the document is ASIM at the end of the day. It has field names that you should use, the values for the events. This example is the schema for audit events. It's a new one that we released just this week. We are updating the number of schemas we support as we go. So some news for you today. Now, beyond schema, we need something to take the events that you send into Sentinel and convert it to the uniform schema. This is code. This code is called parsers, and it's written in KQL. It's just KQL. If you use Sentinel, this KQL is even not a very complex KQL. Just take the table name and do a few simple commands to transform the column names, maybe the column values into the result. Those parsers are saved as functions. And in a second, we'll see how to use those functions to actually get uniform normalized data when you use Sentinel. So let's see a short demo. This demo helps to understand the Advanced Security Information Model, ASIM, Microsoft Sentinel's normalization framework. We will also see how it makes querying data in Microsoft Sentinel easier and more powerful. First, let's see what the data looks like without ASIM. We will start with Zscaler. As you can see, Zscaler sends events in the common event format Ceph. Zscaler DNS events share the common security log table with many other sources. Therefore, to query Zscaler DNS logs, the analyst must know the obscure device product NNS DNS log. Since Ceph is supposedly a normalized format, the result should be very easy to use. But if we look at the record, we notice that the essential values are stored in custom fields requiring significant expertise to use. For example, the response code is stored in a custom field. Now, let's look at the Azure Firewall DNS logs. Again, you can see that the analyst needs to be very knowledgeable to select the relevant events from the Azure Diagnostics table. The results are easier to use as the data relevant to DNS is presented in the message field. While this format is readable to humans, it is challenging to machine analysis, for example, detection rules. Last but not least, let's look at the Microsoft on-prem DNS server logs. Surprisingly, this legacy system provides the most structured logs. However, the DNS response codes are presented in a numerical format, making them hard to use and inconsistent with the other systems we've seen. Now, let's turn to ASIM and see how it addresses these challenges. To use ASIM, use an ASIM view instead of the specific table in your queries. We can see that the fields are returned in a consistent and structured manner. For example, the response code is marked as such and uses consistent labels. Now, repeating the query with a small KQL trick enables us to see a couple of the events from each of the sources we have met. Notice how ASIM queries all data sources at once and makes events from all sources similar. By querying over all similar sources and returning a unified and consistent response, ASIM makes querying easier and enables SOC engineers to create rules once that will work on many sources. So, we've mentioned the two first elements of normalization and ASIM, which are the schemas and the parsers. Obviously, the content, the analytics that either you or we at Microsoft create also have to use ASIM. And here is a very good example of a rule, a simple rule. There are way more advanced rules that uses normalization. You can see here that we use, in this case, the network session schema and parser in order to incorporate every element of information about network that you have and check for port scans in your environment. All we had to do is replace a table name with the parser for network session, and the same logic that you are accustomed to is there, and you can see in the simulation it actually works on your data. An interesting side effect of that is the port scan is calculated over all your sources. So if the attempt to attack a system occurs from multiple sources and is reported by multiple different devices, the attack will still be identified. Anyways, I hope that was a good answer, a very long answer to your question, Chris. Thank you.
So, Ofer, I had a question. So I guess that we from Microsoft, we deliver some parsers that we have developed. Can customers still develop their own parsers, and how do they do that?
Obviously, Javier, parsers are not just for us. One of the main advantages of ASIM normalization is the capability of customers to incorporate their own custom sources or just sources which are not as popular and we didn't cover with ASIM yet by developing a parser. And the documentation has all the information required in order to create a parser. It's just KQL at the end. And we also have the information in the manual on how to incorporate it into the larger framework, where to deploy it, how to include it so that IAM network session actually refers to your parser as well.
Beautiful, thanks.
Excellent, thanks, Ofer. What about transforming the data when it is ingested instead of having to do it at query time? Is that currently possible when it comes to Sentinel, and what are some of the benefits for the customer?
So the short answer, it's possible, but in order to discuss it further, I would want to go and talk a bit about the larger architecture of ASIM to understand the difference between query time and ingest time parsing. So as you know, when we collect data in Microsoft Sentinel, it can get to generic tables such as syslog or core security log or Windows event, or to product-specific tables, or sometimes there are custom tables such as the DNS events table we saw in the demo before, or the AWS CloudTrail tables. Those are not normalized tables. The parsing we've seen in the demo so far is query time parsing. There is a logalytics function which is deployed in your workspace, which knows how to take each specific source and transform it into ASIM. And there's the unifying parser, which is IAM-DNS or IAM network session that I've shown in the demo and into rule later on, that combines using a unit function all of your sources and make it available to the queries, to analytic rules, to workbooks, whether ours or yours. You can also develop over async parsers. Now, query time parsers is very flexible, very easy to use. If your data changes, data still flows in, and you can modify your parser to fit the changes in the data. If you identify something new in the data, a field you were not aware of the structure for, you can still fix, and even backwards. There are two challenges with query time parsing. The first one is that it works, it is slower. It surprisingly worked pretty well, but it is still slower. So for example, the experience in the workbook, which is interactive, might not be as good. The other thing is that we have non-KQL-based machinery, such as UEBA, which requires the data to be normalized in advance. With this in mind, we're using a new feature, log analytics transformation capabilities over incoming data, in order to enable you to write normalized data, your custom data, into normalized tables. We're also creating new connectors that write directly to normalized connectors where it makes sense. And this data is then used also by, say, UEBA or our TI matching engine. So you got the two advantages. It's the parsing is done at ingest time, performance at query time is faster, and all of the Sentinel feature set is working with your data. Now, as a matter of fact, the real expert on implementing ingest time transformation is Javier, who's here with us, and I'll let him demonstrate how to do it perfectly.
Let me try, Ofer. Okay, so thanks, Ofer. Yeah, I'm going to try to explain a little bit what it means to do transformation and ingestion time. First of all, I wanted to show you the documentation. So there's great documentation online in the Azure Monitor official documentation that explains why to use transformations, what are the different use cases that you can achieve when using this new feature, what are the supported tables that allow this feature to be used. It's the majority of them, but not all. So make sure that you look at that article when needed. It tells you how it works and many other steps on how to actually implement the feature. I'm going to show you just briefly how you can do that for one of the tables that we have in the environment. So I'm not switching to the Azure environment where I'm in the Log Analytics workspace view. So you can see this is my Log Analytics workspace called Admin SOC. And now we have a new menu in that view, which is called Tables. If I go to that Tables view, I'll get presented with a list of all the different tables. And then I can filter to see the one that I want, right? In specific example, I want to see the sign-in logs table. Now we have these three dots here on the right that allows us to do several operations. You can manage the table. This allows you to, for example, change the retention that you have on that table. If you want to set it to be retained for longer or to set it to archive, those things you can do them there. You can edit the schema of the table. You can now add new fields, new custom fields to a native table as this one. And you can create a transformation, which is what we want to do right now. Again, the use cases for transformations are various, right? You can use it for filtering, you can use it for enrichment, and you can use it, as in this case that we're discussing today, for normalization. So you're presented first with the basics, and then you have a sample of the data that is being ingested currently into this table. And in order for you to create a transformation, you need to click here on the transformation editor. Perfect. Now we're here, and as you can see here, the table is not called signing logs anymore. It's called source. This is because the transformation that we're doing, it happens before the data actually lands in the workspace. So we're just working with the raw stream that is incoming into the Log Analytics engine. In this case, you can do the majority of the features that we have in KQL, you can use in here. There's some limitations that you need to understand, and that's also documented in the previous link that I showed you. But now I'm going to just do a very simple transformation. So for example, I can try to extend. I can try to extend a new field. We're going to call it geolocation. And then for that, I'm going to use a new function that is actually available just for transformations That is geo_location. And then we can reference the specific field in this log type, which has an IP address, right? If I run that, we'll get a new field called geolocation, obviously, that contains, as you can see, the information about the country, latitude, and longitude of the IP address that is part of the record. You will see this little red mark saying that this function is not available. As you can see, it works perfectly fine. Again, it's only to be used during transformation. This means that basically now we'll get a new field in this table when the data lands in the workspace that will have the geolocation of the IP address involved in the record. This is just one example on how you can use the ingestion time transformations to enrich your logs. The other use case, as Ofer was explaining, is in order for you to normalize the schema at ingestion time. So you can use the same parsers that can be used at query time, can be used here at ingestion time, so the data lands already normalized in your workspace.
Again, thank you all thanks again for your time. Final question here is what can we expect going forward for ASIM?
So a good question. So as you saw, ASIM is here. I think the next frontier is making sure that we at Microsoft, when we create Microsoft Sentinel, take good advantage of it, which means that my journey is to make sure that every team around Sentinel, I think about the wider Microsoft as well, is taking advantage of ASIM, and all the analytics we write is always aligned with ASIM. So more and more features use your custom data and a lot more sources. And the other part is make sure that you are aware. That's why I'm here today. You are aware of ASIM and you take advantage of it to create better content and solutions for Sentinel. So reach out if you have anything about ASIM you want to discuss. Happy to learn and share.
Excellent.
Perfect. Thank you so much, Ofer. Thank you so much for coming to the show. And to everyone that is watching, happy holidays, happy new year, and talk to you again in the next year.
Take care. Happy holidays.
Bye-bye.